This video is an introduction to the CHaMP Topo Processing Tool's Survey Extent tool. And this tool appears in the workflow after you've imported your raw survey data, but before you create your tin. And the purpose of the tool is to draw an initial polygon around your topo data that you can then use as one of the inputs to creating your tin, so that you can clip your tin to your data and it will not interpolate areas that you don't have any data. So the goal essentially is to end up with a polygon that surrounds our data nicely, but does not fill in any of the gaps, the concave gaps between our data. So when you bring the tool up, it asks you for a few inputs. It asks you for topo points and edge of water points from your data. So I can just browse out to those. So I look into my FileGeo database where I'm working on my topo data, and I can choose the topo points. If you're working in projected, your data will be in a projected feature data set, or if you're working in unprojected, it'll be in an unprojected. Mine's in projected, so I go ahead and choose topo points. Edge of water points are optional, but I'm going to choose them here. So I've got my edge of water points there. This tolerance is a really important input, and I'm going to explain more about this in a moment. What it essentially does is points in your data that are less than this distance apart will be considered part of the same polygon and will be included in your survey extent polygon. When the points are further apart than that distance, they will not be aggregated and joined together in the polygon. And so I'll show you this in a second, and we're going to get a really nice example of it in this concave meander right here. So I'll go ahead and run the tool. If you're running the tool multiple times, you'll get this message which says, the survey extent already exists, you want to replace it. And so if you're intentionally running it multiple times, click yes, and it'll overwrite that previous example. So there we are. It's produced a polygon, and it quite nicely captures my data. I used a distance of 20, and so you can see across here, this is about 40 meters across this bend here. And so these points are not, it doesn't attempt to join these points together. It will actually go around this concave bend. But just inside this meander here, you'll see that as it gets tighter into the bend, these points eventually do get closer than 20 meters together, and so it just jumps across. So you have a couple of options here. You can either play with the input tolerance distance to try to get that, reduce the distance so that it will better capture this bend, or you can just go into an edit session and edit that polygon, move the vertices into the meander, and better capture your data. Just to show you what this what I'm talking about here and what it looks like, I've run a few previous examples. So let me just set this up here. And I've used different distances. So when I run, sorry, I just need to get this going. This is what happens when I use a tolerance of 100 meters. You see, these points here are just less than 100 meters apart, and so it immediately joins them together because it knows they're part of the same polygon. And so you get this pretty useless polygon which jumps all of the concavities in my data. Okay, so if I then run the tool at 50 meters, you see it's doing a progressively better job. These meanders are now not cut off, and the polygon is starting to kind of work its way into these meanders. So there's 30 meters. You see it's nicely getting in there. 20 meters. This is the one I ran before. 10 meters. So I'm just going to turn them all off except 10. So 10 does the best job of capturing these meander bends, but you'll notice what it's done here is there are actually some areas in my data where I've got a sparse number of points, fewer than 10, with the gaps of more than 10 meters between them. So it started to come up with these donut holes in my data. And just to kind of show you the extreme case, I also ran it at 5 meters here, and I'll turn everything off so you can see that when you go down to that distance, you actually end up with a lot of holes in your data. So that's completely meaningless. We don't want to go that far down. So really the solution is somewhere between this kind of 10 or 20 meter solution. And you have two choices here. You can either edit the polygon down from 20, which is probably the easiest thing to do. Just come in here and move these vertices into the bend, or you could just as easily go into an edit session on this polygon, delete this donut, and maybe join across this little concavity in the data here. So the end result, as we've talked about, is a polygon which nicely captures the edge of your topo points. You could draw this by hand if you wanted to. This tool is a great way to start out with an initial polygon, and you can go from there. So that's the CHaMP Topo Processing Tools Survey Extent tool.